Question 4 on this week's homework is problem 44 on page 577 of the textbook. And it states, two identical loudspeakers 2 meters apart are emitting sound waves into a room where the speed of sound is 340 meters per second. Abby is standing 5 meters in front of one of the speakers, perpendicular to the line joining the speakers, and hears a maximum in the intensity of the sound. What is the lowest possible frequency of sound for which this is possible? So let's start by sketching the situation that we have here. And so we have, and I'm just going to use the symbol for the speakers again. We have these two speakers, and we know that our speakers are 2 meters apart. And then we have Abby down here. And Abby is standing 5 meters from our speaker. So mathematically, this question is a lot like the one we did on Wednesday's lecture with Cupcake and Joey, the cats. And so the first thing you want to do is you need to figure out what this distance here is, because we know how far Abby is from one of our speakers. We need to know how far away she is from the other speaker. So we're going to use the fact that this is a right triangle. And we're going to use Pythagorean theorem. So we're going to have, let's call this side r, and so we'll have r is equal to the square root of, and then we're going to have 5 meters squared plus 2 meters squared. Take the square root of that, and we're going to get that this distance is about 5.385 meters. So the next thing we need to do is figure out what our path length distance is. So this is our delta r or our delta d. So delta r is equal to, now we have to figure out what our relevant distances are. What are we trying to find the path length distance of? Well, our sound is going to Abby, so we want to find the difference between the paths of the two sounds that are traveling to Abby. So right here, this distance between the two speakers isn't relevant because we're not concerned about how the speakers are interacting with each other directly. We want to know what distance each sound wave is traveling to get to Abby. So our delta r is going to be 5.385 meters minus 5.0 meters. So delta r is equal to 0.385 meters. Ultimately, we want to find our frequency. So the first thing we're going to do is we're going to use our wavelength indirectly. So we know that delta r is m lambda. And so we want to know the lowest possible frequency. Well, the smallest value m could be would be 0, but that's only going to happen if there's no difference between the two speakers, if they're right on top of, in the exact same location. So m equals 0 is out. So the next small situation we could have is m equals 1. In that case, we're going to have lambda m is equal to delta r over m, which is delta r over 1, and our delta r is 0.385 meters. So we'd be left with 0.385 meters. So now that we know our wavelength, we can use our old friend v equals f lambda to figure out what the corresponding frequency would be. So v equals f lambda. Well, we want to solve out for f, so f is equal to v over lambda. And we're going to plug in our values, so we have 340 meters per second divided by 0.385 meters. And this will work out to be about 883 hertz. Now we have meters here and meters here. Those are going to cancel, so they leave us with 1 over seconds in our numerator. And 1 over seconds is the same thing as hertz. Now we have only 2 sig figs here, so we are going to officially round this up to 880, or down I suppose. So our final answer is going to be F is equal to 880 hertz.